Hello, this is the grand finale, our last video on section 6.1. I just wanted to give a few insights as you're approaching the homework and just some ideas. Numbers 1 and 2, we're given a table and we're supposed to figure out if this represents a linear, quadratic, exponential, or maybe none of those. And I want you to remember these are all evenly spaced input values, and that's important. If you have evenly spaced input values and your first differences are all constant, you'll remember that that indicates a linear function. If your second differences, if that's not true, if your first differences are all over the place, but your second differences are constant, that would indicate a quadratic function. And if your successive ratios, like, this one over this one, take any two data points, these are all evenly spaced, and take a ratio of the second one over the first one, and if those are constant, so successive ratios constant, that always indicates an exponential function. And it's possible that none of those things are true, in which case the function is none of those. Number 5 is one of the more challenging questions on the homework assignment, and there are a few different ways you could answer this. All we're told is that this table represents a quadratic function, which is funny that it's in this section on exponential functions. Funny, I guess, that the most challenging problem is a quadratic function problem, but okay, whatever. Remember, so these are the hints I'm going to give you, and if you have more questions, we can talk about it at office hours. Remember that a quadratic function in standard form looks like this. So here are the hints I'm going to give you. We know we're looking for these two outputs. We do know if our input is -2, that the output is 2. So so my output is 2, my f of x is 2, when my x value is -2. So this should be true. When my input is -2, my output is 2. Well, that would definitely simplify to, let's see, this is 4a minus 2b plus c equals 2. Okay. I could actually do that 2 more times because I'm given 2 more input-output values. And I could come up with 3 equations. And if I have 3 equations and 3 variables, remember way back in section 8.1 where we used matrices to solve? And if I knew what A, B, and C were, I would know the function and I could finish those. Okay, that's the hint I'll give you on that one. What I wanted to look at is number 10. It's such a great problem because we're comparing linear growth and exponential growth with the same data. The only hint I want to give you here right now is this data here, this is your important data. Put it in a table. And these are 2 data points in a table. And also remember that you're finding functions, a function of the year since 2000. So the year 2000 would be, your input is 0. Okay, these are 2 data points. With 2 data points, if you have 2 data points, you can find a linear function. You can also, with 2 data points, we talked about this in one of the earlier videos, you can find the change factor and the initial value. And from that, you can find what an exponential function is. So my advice is put these 2 data points in a table. Your input is years, your output is these salaries.